5 more minutes, and what we want to do is we want to extend this approach of actively testing protocols in the internet from not only actively testing what TCPs are out there and what kind of congestion control web servers are using for their TCPs, but also things like what kind of queue management is running in the congested link of a path in a router. And it's a little harder to, from the outside, determine what router is using what kind of active queue management. But it's one of the things that we're looking at. And as a first step, I thought I would just come here and ask people and so I'm interested. One of the things I'm interested in is what routers out there run active queue management such as RED, and I will explain what that is, and what routers out there don't. And then I'll say a little bit about the test that we're planning to check for things like this. I'm Sally Floyd, and I'm also at ASIRI, which is where G2 is from and Vern is from. Sorry. RED, which is Random Early Detection, which is from a 1993 paper that I wrote with Van, is a form of active queue management. And if you're running an active queue management in your routers, that means that you're monitoring the average queue size. And in response to the average queue size, you're dropping packets before the buffer overflows, meaning before you're forced to drop the packets. And the occasional packets that you're dropping serve as notification to TCP to reduce its congestion window, because it's TCP's natural state to try to send faster and faster and faster until somewhere a buffer overflows along the path or until a packet is dropped. That's how TCP is designed. And why would you want to use active queue management? One is that you might want to reduce persistent queuing delay so that you don't have a 100 millisecond standing queue at your router, which doesn't do anybody much good. In some cases, you can reduce unnecessary packet drops by running active queue management. In some cases, by having a lower average queuing delay and a lower round-trip time, you actually might increase the packet drop rate. But in some cases, you decrease the packet drop rate because you're not dropping bursts of packets when only one packet drop would have sufficed to send indication of congestion back to the end nodes. The other reason why we're interested in active queue management is that it's a precondition for using explicit congestion notification, ECN, which is something that's now an experimental part of the IP architecture. And ECN is when the router, instead of dropping a packet to tell the end nodes to slow down, could just set the ECN bit in the packet header, if the packet says it's capable of understanding ECN. And you can't run ECN unless you already are doing some kind of active queue management, unless you're detecting congestion before the buffer actually overflows. So a lot of routers out there have active queue management. I mean, there's weighted red in all of these Cisco routers. Different other routers have different forms of active queue management. My understanding is that it's mostly not turned on in ISPs. And my understanding is it's mostly not turned on because most ISPs say they don't have congestion in the core of their network, and therefore they don't need it. And it's true, if you never have any congestion, you don't need it. It doesn't make any difference one way or the other in that case. But I'm just kind of collecting feedback from people, not here in real time, but afterwards if people send me email about what ISPs are running RED or some other form of active queue management and what ones aren't and what their experiences have been. There's also, I would say, so this view graph says some of the reports that have been written about operational experiences with active queue management. There's other ISPs lately who've been telling me, yes, they're running RED, or no, they're not, and why, and that's interesting. There's a lot of proposals, there's a lot of research papers about other forms of active queue management other than RED, and research papers pro and con about RED, and they're all pointed to on the RED webpage. I'm not going to do that in my 5 minutes. So this is the request, which is that people would let me know in their ISP whether they're deployed RED or some form of RED. If not, let me know that. If they've had problems, I'd be interested to hear that. Are they interested in ECN, or will they be interested in ECN? I'd be interested to hear that. The test that we're thinking of doing to check whether the congested router along your path is actually using active queue management would be tests of seeing if there's persistent queuing delay. So if there's persistent queuing delay, it's not from a routing change. That's an indication that the congested router along your path isn't using active queue management. Another indication would be that there's, for a flow that's sending a conformant rate, it's using TCP congestion control and sending a conformant rate, if there's a burst of drops within a round trip time, that's often an indication that there's not good active queue management. That's unnecessary packet drops. Because TCP only needs one packet drop to be an indication of congestion. But the truth is that the tests for how well active queue management is or isn't functioning in the internet are going to be a lot harder than the tests for how TCP and web servers is functioning. And that's my email address, floyd@asiri.org. There's a mailing list about RED implementation issues. There's a RED webpage. And there's some references for some things in the talk. Thank you.
I have a question. You may have said this, Sally, but I probably missed it. Active tests, passive tests, what kind of tests? Did you say that?
Active tests.
You talked about that.
Mm-hmm.
Okay.
I didn't say much about what kind of tests.
Do you want to talk a little more about, wouldn't that make people concerned? Won't people be more concerned about what kind of tests are going to be?
So the tests that it will be like the tests that we're running on web servers, and that the tests we're running to see what kind of TCP you have at how the TCP is functioning at a web server is to ask for some data from that web server, to at the receiver drop a few packets, report that those packets were dropped, and see how the web server responds. So it's indistinguishable from how legitimate traffic would behave if it had these exact packets dropped that we want to drop. It's no greater load on the web server than that, and it shows how the web server would respond in a real case that would really happen if those exact packets were dropped. It just would be tedious to passively monitor and find a trace in which those exact packets were dropped. It's easier just to drop those two packets and see what the web server does. So tests of active queue management would be exactly the same, and that it would be running a TCP connection that was sending at a conformant TCP sending rate in response to whatever packet drops it happened to see, and trying to infer something about round trip times. And the active part might be sending 2 packets or 4 packets close together rather than spacing them out nicely over a round-trip time to see if a little burst of packets within a round-trip time is more likely to have packet drops, which is exactly what would happen if some incoming ACK packets were dropped. So it would be, the tests would be running a TCP connection that would be indistinguishable from many other TCP connections going over the link. Not congesting the link where there wasn't congestion. It wouldn't be running a really heavy TCP connection, cray to cray, trying to congest the link that wasn't already congested. But it would be trying to figure out good ways to run a TCP connection and to infer from the behavior of the link and the round trip times how well active queue management was performing along the congested link in that path if there was such a congested link.